Hello students. Today we are going to learn one of the important part of this eigenvalues and eigenvectors topic, that is properties of eigenvalues and eigenvectors. This is very important for exam point of view. The question 5 marks question based on these properties will come in question number 1, generally what we have observed from the past papers. So let us try to understand what are the properties of eigenvalues and eigenvectors. You see this table. This table, in this table, I have considered lambda is one of the eigenvalue of A. You can see here I have considered lambda is one of the eigenvalue of A, and I'm going to find eigenvalue of this function of A, right? This is also a matrix. Okay. So if lambda is one of the eigenvalue of A, then I'm going to tell you what are the relations in eigenvalues of A raised to n and so on. So you can see here, this is A raised to n is there. So eigenvalue of A raised to n is lambda raised to n, because I have considered lambda is one of the eigenvalue of A. So eigenvalue of A raised to n is lambda raised to n. Then you can see second term is A square. Okay, so what will be the eigenvalue of A square? Because lambda is eigenvalue of A. So lambda square will be the eigenvalue of A square, right? Then you can see here, third term is A dash. Okay, so eigenvalue of A and A dash both are same. So here I have written lambda. Okay, plus sign is there, that's the reason I have written plus. If minus is there, you can write minus, doesn't matter. Then you can see the next term, which is A inverse. So eigenvalue of A inverse will be 1 by lambda. Okay, because I have considered again lambda is eigenvalue of A. So eigenvalue of A inverse is 1 by lambda. Then you can see 2i. So 2a, right? For A, we have considered lambda. So 2 lambda is eigenvalue associated with 2a, right? Then plus 3 into I. In place of I, you can write down 1 here. Okay. So this is the eigenvalue of A raised to n plus A square plus A dash plus A inverse plus 2a plus 3i. Is it clear, student? For A inverse, 1 by lambda, right? You have to remember this. Okay. And for A raised to n, lambda raised to n is there, right? And for I, you can write down 1 here. These are just, I'm highlighting what are the changes. Remaining all is for, no, okay, you can understand it. Now, you can see the next I have written here Ka, right? So what will be the eigenvalue of Ka? So you can keep K as it is. It is any number, a real number. And for A, we have considered lambda. So K lambda is the eigenvalue associated with lambda for A. Then you can see here adjoint of A is there. For adjoint of A, eigenvalue of adjoint of A is determinant of A upon lambda. Okay, so in this way you can write down. Now you can see here determinant of A equal to 0. Then we know one of the result that product of eigenvalues is equal to determinant. So if determinant is 0, this implies that at least one of the eigenvalue must be 0. Clear? Okay. And very important about eigenvectors, remember. Eigenvectors of A, right? And eigenvectors of, any combination of this matrix A, right? Function of A are same. Okay, eigenvectors of A and eigenvectors of f of A are same. Okay, let me explain you this with one example. So here, this example is, A is equal to 2, 2, 1, 1, 3, 1, and 1, 1, 2. And we have to find characteristic roots, means eigenvalues, right? Means we have to find eigenvalues of AQ plus I, okay? And characteristic vectors means eigenvectors. All of you remember, characteristic vectors means eigenvectors of this function of A. Okay, we want eigenvectors of this. So what we have to do initially, first you need to find what are the eigenvalues and eigenvectors of A itself. So here I'm not going to explain in detail. Directly I'm going to give you what are the eigenvalues of this A. So eigenvalues of A are suppose 1, 1 and 5. Okay. Then what will what will be the eigenvalues of AQ plus I? Here you can take 1 is the eigenvalue of A. So eigenvalue of AQ plus I is 1Q plus I is 1, right? Second eigenvalue is again 1. So second eigenvalue of AQ plus I is again 1Q plus 1. Third eigenvalue of A is 5. So here 5Q plus 1 is the eigenvalue of AQ plus I, right? Then if you simplify this, you will get here 2, here also 2, and here 125 plus 1, which is 126. So 2, 2 and 126 are eigenvalues of AQ plus I. Clear? No need to calculate AQ plus I, and then if you find the eigenvalues, you will get the same answer. Okay? Clear? So you can save your time. Now, what is asked here? Characteristic vectors means eigenvectors of this polynomial in A, right? But we have the result that the eigenvectors of A and f of A both are same. Here they have given in this example, these are eigenvectors of A, right? So if eigenvectors of A are -2, -1 and 0, if this is the eigenvector, right, then eigenvector of this polynomial is also, first eigenvector is this, right? Then the second eigenvector is 1, 0, -1. This is the second eigenvector associated with this. And the third eigenvector is 1, 1, 1, right? So by with this result that eigenvectors of A and f of A are same. So with this result you can say that eigenvectors of A and eigenvectors of this function of A are same. I hope this example is clear. Now we will move to the next example. You can see this example. This is again one of the university example. In this example, uh, we need to find characteristic roots, means eigenvalues of a raised to 30 minus 9 into a raised to 28, where a is this. So let us calculate first of all what are the eigenvalues of this a. So we need characteristic equation 1 minus lambda, then 2, 2 and 1 minus lambda. I think we have solved this example also. 1 minus lambda bracket square minus 4 equal to 0. So if you simplify this, we get an characteristic equation lambda square minus 2 lambda minus 3 is equal to 0, and lambda is equal to minus 1 and 3. These are eigenvalues of A, right? But we want eigenvalues of a raised to 30 minus 9 into a raised to 28. So first of all, I'm going to consider minus 1. Okay, just you can put here minus 1 raised to 30 minus 9 into minus 1 raised to 28 minus 1 raised to even number is plus 1 minus 9 minus 1 raised to 28 is also plus 1. So 1 minus 9, this is equal to minus 8. So minus 8 is the eigenvalue of a raised to 30 minus 9 a raised to 28. This is one of the eigenvalue. Now let us calculate the second eigenvalue. So here for a, lambda is equal to 3 is one of the eigenvalue. Now let us calculate. Here you can replace a by 3 now. So 3 raised to 30 minus 9 into 3 raised to 28. What we have to do? You can take 3 raised to 28 common. So 3 square minus 9. Then 3 raised to 28. 3 square is 9 minus 9. This is equal to 0. So 0 into anything is 0. So eigenvalues of a raised to 30 minus 9 times a raised to 28 are minus 8 and 0. I hope this example is clear. Okay, now we will move to the next example, similar type of example. Now here, this is one of the university example. Remember, here the given matrix is, upper triangular matrix. So we know that if matrix is upper triangular or lower triangular or diagonal or scalar, all of you remember that the diagonal elements represent the eigenvalues of this matrix. Okay, so here lambda is equal to minus 1, 3 and minus 2. These are eigenvalues of A. Okay, now, but we want eigenvalues of A cube plus 5a plus 8i. Okay, so first I'm going to consider minus 1 here. So you can put here minus 1 cube plus 5 into minus 1 plus 8. I you can replace by 1. So minus 1 cube is negative 1, negative 5 plus 8. So this is negative 6 plus 8. This is equal to 2. So first of all, 2 is the first eigenvalue of this given polynomial in A. Now, corresponding with 3, so I'm going to write 3 cube plus 5 into 3 plus 8 into 1. So this is 27 plus 15 plus 8. So this is equal to 50. Now, the third eigenvalue corresponding to minus 2 is minus 2 raised to 3 plus 5 into minus 2 plus 8 into 1. So this is minus 8 minus 10 plus 8. So this is equal to minus 10. So what are the eigenvalues of a cube plus 5a plus 8i? Are first of all 2, then 50 and minus 10. So these are eigenvalues of given polynomial. I hope this question is also clear to everyone. So in this way we have covered one of the important and small article, that is properties of eigenvalues and eigenvectors. So with this, thank you very much.